Hi everyone, it's Mrs. Eggerding again, and you're watching video 4 for this unit on polynomials, and we're going to talk about the basic graphs of polynomials. Polynomials pretty much come in two different groups. This first graph here you should recognize is the graph of x squared, sometimes called a parabola, and it has specific ordered pairs 0, 0, 1, 1, and negative 1, 1. And then 2, 4 is on here, and negative 2, 4, graph of a quadratic. Next one, if you notice, is x to the fourth. If you notice, x to the fourth looks really, really similar, just a little bit skinnier. It still has 0, 0, it still has 1, 1, it still has negative 1, 1, but 2, 4 is no longer here because 2 to the fourth power, that's going to be up here at 2, 16, and the other one's going to be at negative 2, 16. Because you're raising it to the fourth power, it gets pulled up a lot faster. Another one that we talked about first semester was x cubed. It also has some good ordered pairs, 0, 0, 1, 1, negative 1, negative 1, because this odd power gives me an odd result. It has one x to the fifth, and if you notice, x to the fifth has a very, very similar shape. It also has 0, 0, 1, 1, negative 1, negative 1, but again, it's going to be pulled skinnier. Again, if we look at 2, this one would have the ordered pair 2, 8. Here, it's the ordered pair 2, 32. So you can see it's just going to get pulled up a lot taller. These two groups, based on the shapes, one group has parabola-looking shapes, one group has these S-looking shapes, and we actually call them even polynomials and odd polynomials based on their exponents. The even polynomials are going to have parabola shapes. Their domain is going to be all real numbers. And their range is either going to be negative infinity to some value, k, and we don't know what that is just yet, and that's if the parabola shapes are going down, or it's going to have a range starting at some value and going up to infinity, and that's if the parabola shape goes here, and here's that k value that sets it. The exponents on even polynomials are going to be even. Odd polynomials are going to be the ones with the odd exponents. They're going to have this S shape with a domain of all real numbers and a range of all real numbers. Okay, even polynomials are also defined based on their symmetry. They will have symmetry on the y-axis. So this axis of symmetry that cuts a parabola in half is going to be on the y-axis. Odd polynomials have symmetry too. Their symmetry, though, is about the origin. 0, 0, and it's what we call a rotation symmetry. Basically, if you turn it upside down, it's still going to look the same way. Okay. The third thing about these polynomials is a couple of the ordered pairs. Even polynomials, and you saw from the ones we did, have the ordered pairs negative 1, 1, 0, 0, and 1, 1. in common. Other ordered pairs on here are going to depend on the exponent that you have. The odd polynomials, -1, -1, 0, 0, and 1, 1. And again, the rest of them are going to depend on what exponent you're dealing with. So those are the basic information that you need to know about the even and the odd polynomials. Now we're going to go back and talk about the transformations. This kind of notation should look really familiar to you. We've used it with absolute values. We used it with quadratics. Here, though, I'm just going to talk about any generic exponent on that end there. First type of transformation is a reflection or a flip, in other words, turning it upside down. And this occurs when the value of a is negative. And what that does is it's going to flip an even function upside down, and an odd function, instead of going down up, starts up and comes down. And that's what the flip looks like. You also have the stretches or compressions. Basically what that means is as the a value gets bigger, that's going to stretch the graph, and as the a gets smaller, I don't want to say gets smaller, but gets closer to 0. Closer to 0, that's when you get a compression, or the graph starts flattening out or getting fatter. Vertical shifts up and down, those are going to be the values for k. If the k value is greater than 0, that's going to move the graph up. If the k value is less than 0, that's going to move your graph down. And the last one is your horizontal shift. That's the left and right. That's the inside. So the h value, if it's greater than 0, that's going to be right. If this h value is less than 0, it will be left. Keep in mind on the horizontal shift, though, because it is x minus h, when you get the h being a negative, it's going to be minus and negative, so it's going to look positive. You have that it looks backwards thing going on. Let's practice with these two here. First one is x to the 5th minus 2, and the first thing I'm going to notice about this is that it is going to be odd, so the shape is going to be that S-curve shape. The other thing I'm noticing is the minus 2 on the outside. That tells me my graph is going to go down 2. So if here's my coordinate, I'm going to go down 2. And then I can plot a couple other points and make my S shape. I know the domain of this is all real numbers, and my range of this is also all real numbers. For this second one, I'm going to notice that my exponent is even. That means I know I'm going to have a parabola shape. It's moved, the plus 1 means it's going to be moved left 1, because this is written x minus -1, and so my h value is negative. The plus 3 means it moves up 3. So from 0, 0, I'm going to go left 1, up 1, 2, 3. That's where my vertex is. And then I can plot a couple other points. And I know it's going to look like a parabola. Domain, all real numbers. My range, this is the only thing we need to worry about. The range, it starts when the y coordinate is 3, and it goes up towards infinity. Very, very similar to absolute values and quadratics, just a little bit new vocabulary with the even and odd. So the homework is 13 through 19 odd, and as you're doing those, make sure you include the domain and range. Check your answers. There is also a short little quiz for video 4 entrance slip that you can take on Schoology, and that score will be part of your homework. So after this, we're going to make sure you can sketch the graph using the transformations, state the domain and range, and start to have a feel for the difference between an even function and an odd function. Bring your questions to class, and we'll see you in a little bit.